plus a transition takes place from the orbit of radius 1058 picometer to the orbit of radius 26.45 picometer. The wavelength in nanometer of the emitted photon during the transition is. We have to calculate the wavelength of the emitted photon. And Bohr radius, Rydberg constant, Planck's constant and speed of light are given. Now we can calculate the orbit numbers first, because the radius of orbits only given. We have to calculate from which radius to which orbit the transition takes place. For that we can use the formula R equal to 52.9 into n square by z. Here 52.9 I am using because the units are given in picometer. Now I am using 105.8 picometer as the first step. 52.9 into n square divided by, for z I am using 2, because the value 2 comes from atomic number of helium atom. Now I am rearranging this. N square equal to 2 into 105.8 divided by 52.9. On cancelling this I am getting 2. So n square equal to 4. Therefore n equal to 2. So I am labeling this as n2 as 2 because it is the second radius. Now I am calculating for the first radius. That means 26.45 equal to 52.9 divided by 2 into n square. Similarly, I am taking n square to one side and all the other terms to the other. 2 into 26.45 divided by 52.9. On multiplying 2 and 26.45, I am getting 52.9 divided by 52.9. On cancelling this, I will be getting 1. Therefore, n square equal to 1 and then n value will be 1. I am labeling this as n1 equal to 1. Now we have arrived that the transition takes place from the first orbit to the second orbit. We know that delta E equal to the energy of photon emitted, which is equal to h mu. Also mu equal to c by lambda. Now from this I can arrive the value of lambda. Therefore instead of mu I can write c by lambda. Also delta E equal to RH into z square by 1 by n1 square minus 1 by n2 square for emission. For absorption it will be n2 square minus n1 square. I am equating these two equations. I will be getting hc by lambda equal to RH z square into 1 by n1 square minus 1 by n2 square. Now I am substituting the values. The value of h will be 6.6 into 10 power minus 34 into the value of c will be 3 into 10 power 8 divided by lambda, and then the value of RH is 2.2 into 10 power minus 18. We know the Z is atomic number. For helium it is 2, so I am taking 2 square, which is nothing but 4. 1 by n1 square is 1 minus 1 by n square is 1 by 4. So I will be getting 3 by 4 as a value. It comes from 1 by n1 square minus 1 by n2 square. On substituting n1 I will be getting 1 minus 1 by 4. So 1 quarter has been reduced, which is nothing but 3 by 4. Now we can solve this equation. 4 and 4 will get cancelled, and 3 will get cancelled, and 2.2 here it is 6.6, so 3. Therefore the value of lambda equal to 3, On summarizing all these things, 34 and 18 will be cancelled, 16. So I will be getting 8, which is nothing but 3 into 10 power 8. Instead of that, I can write 300 Armstrong. The value has been asked in nanometer. Therefore, I can convert this Armstrong to nanometer as 30 nanometer. So the answer for this question is 30.